Assalamualaikum and good evening, Dr. Hamid. We from Group 2 will present about Project 2, which is focuses on toolware and chip breaker analysis. There are 3 people in our group, including me, Muhammad Khwarizmi, my friend is Muhammad Muizuddin, and Watson Ifpi. Definition of toolware. Toolware is the normal use related, slow breakdown and failure of cutting tools. Throughout its lifetime, every tool will experience toolware. There are a number of factors that contribute to tool points wearing out quickly, and solution will be provided. Definition of a chip breaker. Continuous chip can be problematic for ease of handling and to avoid creating a safety hazard at work. They should be broken into relatively small pieces, as the sword is formed with the aid of an operation attached to the tool face. Chip breakers are used to break it up into smaller pieces. Problems with handling and disposal of continuous chip are caused by continuous machining, such as turning of ductile metal. The use of chip breaker become crucial in that situation. This kind of chip is known as a discontinuous chip. As the diagram shows, where this chip can be seen when the workpiece is made of brass, bronze, or cast iron during the machining process. Low feed rate, low rake angle, high cutting speed, high tool chip friction are the conditions that promoted the formation of such chips. Continuous chip are the name for this kind of chip. These chips are byproduct of the machining of steel and aluminium, where the cutting speed of this process is high. This type of chip is produced for a number of reasons, including small die of cut, cutting speed, high cutting speed, low toe friction, and sharp cutting edge. For the toolware, every time a tool is used, it will deteriorate. Identifying the profile of the tooling will allow you to determine whether toolwear has occurred or not. Toolwear depends upon the following parameter, which is tool and workpiece material, tool shape, cutting speed, feed and depth of cut, cutting fluid, machining tool character, and so on.
Here my part is type and latest technology we use. Number 1 is a Dinolite digital microscope model AM7012MZT. Number 2 is Dinocaptor 2.0 software. Dinolite digital microscope model AM7012MZT is a digital handheld microscope that lets sitting clearly and in detail. This has a 5 megapixel sensor that can magnify up to 200 and adjust the polarization of light. They also have a microtouch sensor for taking picture, built-in LED for lighting, and Dinocaptor 2.0 software for recording video and anything image. They can also measure and calibrate objects with this microscope. The AM7012MZT is made of aluminum alloy for protection and durability. This is a professional tool for observing and analyzing objects under any manipulation and polarization. For Dinocapture is a software for Windows that allow you to use Dinolite USB microscope to view, capture, measure, annotate, and share image and video. This has many features and functions to enhance your microscopy experience. So has polarization, calibration, time lapse, egg detection, barcode recognition, GPS integration, and more. And next part is the is least path or linear line. In this part, I will show the path or linear line Microsoft model AM7013MZT and the function of the path. Number one is microscope body, the metal housing that contains the sensor, lens, LED, polarization, microtouch sensor, and other components. Number two, USB cable, the cable that connects the microscope to the computer. Number three is cap closure, the removable cap that cover the lens and protect it from the dust and damage. Number four is a microtouch sensor, the small button on the side of the microscope that allow you to take a picture or control other function with touch. Number five is LEDs, the white LED that provide illumination for the object under observation. You can adjust their brightness and turn them on or off with the software or the microtouch sensor. Number six is a polarizer, the built-in adjustable polarizer that reduces glare and reflection on seen object. Number seven is lens, the glass lens with anti-reflection coating that provides magnification and focus for the image. You can change the magnification by adjusting the working distance between the lens and the object. The magnification range is 20 to 50 and 200. Number 8 is sensor, the 5 megapixel CMOS sensor that captures high resolution image and video. The resolution is 2592 multiplication 1944 pixel and the maximum frame rate is 30 fps. And next part, I will give Muiz.
Next is toolware analysis before and after. Finally, the presentation I made was the result of the research that was done on toolware and chip breakers based on the selected project, which is a lead tool point has 3 edges. This presentation also shows the difference between used lead point and new lead cutting point. Many different can be shown and are in line with the result to be obtained in the objective of this project tool. The lead tool we use for this project tool is a tungsten carbide which has 3 corners and edges. The point of this lead has its own chip breakers which help to remove chip more easily and well. The first picture before is unusual point tool or new lead cutting tool. If you look closely using a dyno light microscope, it has no effect and has a good profile. The next picture shows after the cutting tool has been used. According to the observation made, after using the point of tools, it has left a mark or what is known as flank wear. The flank wear area is 1375 square millimeter. Next. The third picture shows a picture on top of the lead cutting tool has not been used. If you look closely, the surface of the chip breaker has no traces. The fourth picture shows the lead cutting tools that has been used for the lead process. In the picture, if you look carefully, it has an effect called creator wear. The creator wear that is on the point of the tool is 3.535 millimeter square. Next is chip breaker analysis, which is has a big chip and medium chip. Now I present about chip breaker analysis. Here I will tell about the chip will be removed from the machining process. The chip that come out will flow the characteristic of the point of the lathe tool. The first chip is classified as type A, which is a small depth cut of less than 7 mm to 15 mm. For the medium chip, he is classified as type E, where it is less roll than half a roll. And finally, the small chip. The small chip is classified in the type C class. The class has a good cut. This class also have a good roll, 1 to 50 mm and 1 to 5 roll. It is also called continuous chip. Cutting the removed type C chips will leave a good surface roughness. And then, conclusion. The selection of the tool point and also material is something important to achieve specific objective, such as, for example, of obtain good cutting quality or obtain the necessary surface roughness, as well as each point the cutting tool has its own characteristic, so that machining work can be carried out with quality and meet the specification that have been set. That's all from our group. Thank you.